Yeah.
Okay.
I suppose we got enough people. We get going.
Yeah,
John,
because
are you the
I'm sort
moderator
of the
today?
moderator or whatever. Carl's had surgery on his arm.
Oh,
So
okay.
yeah, it sounds like it will be a couple months of rehab. It seemed as the shoulder blade or the socket, he was describing it to
Oh,
me. And so yeah, it's so tonight I don't really anticipate him to be on even.
Okay.
So
or he'll
with
be
that,
in a drug-dazed state, maybe.
yeah, well, that's sort of what he implied today would be. But yeah, effectively he was, yeah, wasn't going to be that wide awake, I imagine. So, and also right now, at least at this moment, we're not recording it unless Doug, you want to try.
I'm recording.
Okay. So with that, I guess we'll start off with. I don't know what subject y'all want to talk about now, since we already talked about computers and punch cards, but which is indirect related to it.
Hey, how about
So
let's talk about robots?
Yeah, I've got something I'd like to say. Uh,
okay,
uh, I just got some new sensors from Pololu that I'm finding very interesting. They're essentially uh, they're lidar sensors, but they're packaged and the outputs are different. They're very small. Here you can see I'm working on this robot. I've just put 3 of them in the front. Okay, so they're about a ½ inch by 1.5 inch, I guess. I mean, just guess.
Yeah.
And what they have is a little different. Uh, they have a output that is a pulse.
Oh, yeah.
And so,
PWM
no, it's not really PWM per se. It's
or
a
pulse position.
it's well,
Yeah.
it's a pulse that if it's right up if you're right up against the sensor, it's 1 millisecond. Okay, and it's as you get further away from the sensor, that pulse lengthens. Okay, to about 1.75 milliseconds, and that's right at 130 millimeters. So if it's 50 inches, I think they said, whatever 130 millimeters is. That's so the
Ah,
50,
about
50, 50 inches is pretty far for a nice infrared sensor. Again, this has some things about it. Like for example, if you're using a piece of white paper, it's real easy. If you're using a black ruler, it's a little harder. But it seems to work real well. I'm trying, and they have a refresh frequency of 100 hertz. So that means that's pretty good, I mean, uh, so they say it takes about 10 milliseconds. Well, if you think of 100 hertz, 10 milliseconds for them to be able before they start pulsing again. And they pulse continuously. However, they do have an enable pin that you can control. You can either so you can turn them on and off. But my goal is right now is to have all 3 of the sensors actually pulse independently, so that you can't have they'll be asynchronous, but uh, having using pin change interrupts to try to allow them to all fire at the same at their full rate, whatever they're doing. So I won't have to do this fire 1, fire 2, fire 3, fire 1, fire 2, fire 3. That's a lot easier to do, and it may not make that much difference because the whole time would be roughly 6 milliseconds. But I would like to be able to just shoot them out all at the same, and that program has taken me a little bit more time than I anticipated. So the part is 4071. That's the one I'm using. Let's see if I can find Pololu.
Well, Doug, these I think Pololu has been kind of marketing them. These are the standard sharp sensors, those
Yeah.
analog infrared ones, and I think they have the same circuit board size as these.
Yes.
And
Yeah,
and
they do.
so they've kind of marketed them as a replacement for these sharp ones. And so the one question I wasn't clear on is that if you have, let's say, I've got like this is a mock-up of the 5 I have on the front of my robot, just as a test
Yeah,
run.
yeah.
And if you are to fire all 5, aren't you going to get crosstalk between them?
Well, it depends on how you got them set. They have a cone of roughly 15 degrees.
Mm-hmm.
All right. So on my particular application that I'm going to start with, I'm not saying this will end up this way, but if you look at this carefully, let's see if I can do this.
Well, I get your point
Yeah.
about aiming them out, you know,
So,
but
yeah.
if you were driving your robot around and you came upon a reflective surface, I guess it doesn't really matter which one is the one you're reflecting back on. As long if you fire them all at the same time and you get a reflection on any one of them, you're getting a distance measurement, I guess.
Yeah. Well, another way of thinking it is, I typically use a loop time of 20 milliseconds.
Right.
So, you know, these things are firing off, you know, I get 2 readings per loop. So, you know, what I'm saying is, this is the first time I've looked at one of these little LiDAR sensors where the actual using of it seems simple. All right. I mean, the other ones worked on I²C, and yeah, that should have been simple, but they had some funkiness to them. For example, they all came with the same address. So if you had multiple ones, you had to turn one on, change its address, turn it off, set up the next one, change its address, turn it off, and you know, it was just a lot of little crappy things that you had to put up with.
Are they time of flight or angle?
They don't say anything about the sensor.
Okay.
Okay, but
It looks like the time of flight because
I agree.
The sensor, they have other boards, you know, with I²C and so on.
Yeah.
It looks exactly like those ST microelectronics time of flight.
Right, and the other thing about them too is they have, I believe, a microprocessor on the back side of it. So what you're getting here is a smart sensor. All right. And so they've actually got 6 parts out there. 3 of the parts are just distances. Otherwise, they're what do you call them?
They're digital.
Trip. Yeah, you trip them. You know, if you're within their range, they trip, and you know that you got something in front of you. Then they have 3 that are using this pulse system that I described. Now the thing about them, so they have one that's now I don't know, 50 centimeters or something like that. They have this 130, and then they have one that's like 200 or 300. It's pretty far. Mm-hmm. Now, and the thing about it is, if you look at them, the refresh rates on them are different, and also the resolution, because the pulse is the same on all of them. And in theory, if I read it right, and again, take this with a grain of salt, they have 4 configuration resistor locations, and the configuration that you buy comes with the resistor in the right spot for that configuration. But if you wanted to, you could take that resistor off and put it in one of the other 3 locations, and you could change the style of the sensor. Now, I don't know if you could change it from one that's a actual distance information to one that's just a trip. I don't know if you can cross that boundary, but you probably can do all of the distance ones and all of the trip distances. So, and they're on sale right now. So they're about, I want to say they're right now they're just under $10 a piece.
So I found them on the website, but they're short distances, like 6 inches. The biggest one I found was 20 inches.
No, the one I'm looking at is a 200 centimeters, so it's about 2 meters.
Ted, go to Pololu, up in their search box, just put 4071.
4071. Okay.
Yeah, and 4077 is the 2 meter one.
Yeah.
Okay. Yeah. Okay. I found the wrong sensor, I guess.
Yeah. Well, it's easy to do because they've got, like I say, they've introduced 6 or 8 of these variations, okay? And
Yeah.
so, I hadn't seen them before, so I think they're fairly new.
They are new.
And I was just, like I say, the one that's 130 millimeters, seems to me it's got a fast refresh rate,
Centimeters.
and the resolution is 2 millimeters. And I just set them up, and I set up one and let it run, okay? And then I went and took the average and the standard deviation. And so I was getting, for a reading that was about 500 centimeters away, I was getting a nice, what's the word, Gaussian curve. And they were about a standard deviation of about 5. Okay, so they looked, for the type of sensors that we really need. Okay, I'm roughly a foot away from something. I better do something. These look really good. Now, there's a couple of questions. I haven't used them outdoors yet, so I don't know if they would be something that you could put on a rover. I can tell you that the sharp sensors do work outside. Reduced capability, but they do work out there. So I'd have to check this out. That's one thing. Might have to do some shielding. I don't know. But like I say, these sensors look to me. If you got the cash, I would say these would be worth buying at least a couple. You can get 3 at a sale, and if you make a sale and on another day you can get 3 more. But I just wanted to make everybody aware, because like I said, I hadn't seen it before. I think these might actually be good sensors. I'm real pleased with it. I'm glad. I mean, I'm right now I'm pretty stoked on them because they seem to be measuring well. They seem to have good resolution, and I haven't had any problems with them.
Well, Doug, I'd have to say that I have looked into these because I had just went ahead and purchased that group of 5 of the analog sharp sensors, and I had kind of had to figure out whether I wanted to go with these or those. But the one thing I liked about the sharp was that they give you an analog output, and I'd already gone to the trouble of calibrating that, so I got actual measurements in centimeters.
Yeah.
With these, I haven't bought one, so I haven't tried to convert that pulse width into a measurement. But I do know that the ones there seems to be 2 styles of the actual sensor, not the carrier board, and one has a little black sensor with a little hole in it, and the other one has 2 little squares.
The 2 little squares is going to be the long distance one.
Yeah, and the 2 square ones are the PixArt sensors. So I've used those. That's the one that's the same sensor that's on one of the Pimoroni boards, and those do work just fine outdoors. There's no issue at all.
I wouldn't be surprised by that, Murray. And I'm just saying I haven't done it yet, so I don't know.
I had mounted on a servo and do a sweep with it, and it gives me a very, very accurate output.
Yeah, the nice thing about, like I say, that I have about this is they're so easy to use. If you're just using one, and you're using Arduino, you essentially just have to use pulse in, and it'll do it. But since pulse in is blocking, that might not. If you're using multiple sensors, you may want to approach it a different way, and that's why I'm saying right now I'm trying to use pin change interrupts to do it.
It's almost like treat it like a sonar, right? Except you don't have to ping it.
Right. Yeah. Yeah.
Murray, have you tried yours outdoors?
Well, I have a different sensor. I don't have these Pololu ones, but it's the same PixArt hardware. And yeah, I've mounted it on the sensor on the front of my robot and driven it around outdoors on my front deck, and no problem at all. No.
In the sunlight, daylight?
Yeah, just regular daylight, and with sun. I don't think that they're particularly. I mean, maybe into bright sunlight, which I didn't shine it right into the sun, kind of thing. But I don't think that they're particularly affected by sunlight. They're sending out a pulse of a certain frequency and looking for the reflection of that. And it doesn't even have, and the amount of light that comes back into the sensor at that frequency is extremely small. They're very, very sensitive sensors. So I'd be surprised if they have trouble maybe in bright sunlight. I don't know, but
Yeah, well,
I run it around in the middle of the afternoon and had no problem at all.
yeah. Here in Texas, though, you got to assume it's going to be over 100K lux. So
Well, you have to note that in New Zealand, actually, our ultraviolet is a lot higher than yours.
yeah, but I'm just saying is that I've had situations where on a nice, what I'd call pleasant day, the sensor works great, but you get it in Texas bright sunlight, it just dies. So I gotta, I just gotta try that, and hopefully, if I get this program running, that's going to be one of the first things I want to do, because obviously I like to have, they're so easy to use. I'd like to have them on my rover. So let's see how that goes. So
yeah, that's exciting. I'm going to take a look at that, because I've been using the TF Mini LiDAR sensors, which are a lot more expensive, and they work off of UART, which is just kind of annoying to deal with.
yeah, well, I've used those too, Ted, and there's even on, if you go, I can't remember where it is, but there's actually I did some work with them, and it's on a YouTube video that's in the DPRG clips channel. So
Okay, I'll look for that.
Yeah, it's well, it might be easier to just go through the website, just page back in the history, and that you can see it's embedded in one of them. And I actually used that outdoors, and what I found was they get inaccurate at 12 meters, but they do detect out to 12 meters. I mean, so they're, 12 meters might be really, 10.5 meters, but at 12 meters, you usually don't care. You know
Right,
what I'm saying?
exactly. And I'm more concerned about the shorter distances with that.
Yeah. So, that was where I was going on my rover to start with. I'll probably have one mini micro on there. The problem with it is, you only have so many UARTs, and before you know it, you run out of UARTs. All right. So that was the thing I wanted to bring up. I thought it might be of interest.
So I've been using the Teensy microcontroller, and you can put a whole bunch of PWM inputs on that. And
which one are you using?
The 3.5, mostly because it has plenty of memory and it's 5-volt tolerant, so I don't have to worry about that.
Hey, Dave. Yeah. Yeah. I followed the Teensy, and I got, I have a 3.1 and a 3.2, so I have to use those up before I go to the new ones. So
the 3.5 also has an SD card reader, which is really nice for logging and that sort of thing.
You have to play with the toys you have.
Yeah. I mean,
All right,
I'm going to die here, and I'm going to have a closet that's a history of weird stuff from this time period. So, gotta at least put it on something.
I have a question for the group. I'm working on a PID controller for my robot's velocity. In the past, I haven't really worried about velocity because I just run robots on flat, smooth surfaces, and I just set a throttle, and it tends to go at about the right speed. But going outside, going uphill and downhill, you want to control the throttle a little better.
Yeah.
So in the past, what I've done is I've done PID controllers for going to distance or turning to a heading. And in that case, driving to distance, if you're a long ways away, there's a big error. And that means your proportional goes way up. So your motors spin fast. And as it gets closer, they spin slower. And then it stops when it gets there, hopefully. But like with the velocity, if it's sitting at 0 and it wants to drive at say 10 feet per second, then there's a big error, and the throttle goes to 100%, and then it quickly gets to 10 feet per second, and the throttle, there's no error, so the throttle goes back to 0, and I get all this jerking.
Yeah, that sounds like bad tuning, Ted.
Well,
No, it sounds like
need
you need to watch David's presentation.
Yeah, you need to watch David's.
He didn't really talk about that. I tuned it by having no proportional control gain. The proportional gain was 0. I had a huge integral gain and pretty much no derivative. And that slowly, it slowly works its way up, and then it overshoots and it slowly comes back down. And so the next thing I did is I said, well, I know about what the throttle is supposed to be set to. Like say I want to go at half speed, I set the throttle to 50%. And then I add in my crazy PID controller with just the integral gain. And that sort of works, but it seems like I'm doing something very wrong here.
You're missing the motion profile. I'll let David explain.
What you're doing is called feed forward, and it's actually an advanced PID concept. So you're not cheating, you just discovered something on your own.
But what you're missing is the slew rate, right? In a sense, you don't want to go from 0 to 100 in an instant.
Let me back up a little bit. When you're sampling your encoders, you're sampling. Okay. Are you sampling their total accumulated rate counts, or are you resetting them to 0 every time you sample them?
Let's see. So I'm computing the instantaneous velocity by taking the period I just measured and subtracting the current value from the last.
So you're taking the derivative, so it really is the velocity. Just wanted to be sure about that. Okay, so then when you start off, say you're at a certain speed, you want to go another speed. Are you the error is the difference between the velocity you measured and the velocity you want, right?
Correct.
That's the proportional error. So PID controllers are just fancy proportional controllers. So forget about the other two for a minute. So the further away that target is, the larger the error is. Now, when that error goes to 0, you don't want your control voltage to go to 0. You just want it to stop changing, right?
Right. And that's what I can't figure out how to get it to do.
Okay. So I'm going to cut to the chase here. The PID controller I use is actually a PD controller that drives the I value. So think about the I value like the position of your accelerator on the floor. And you're going to push it down and pull it back up based on whether you're moving faster or slower than the required velocity. So what you want in that case is for the error to go to 0 when the velocity is correct. That way, when you integrate every time around the loop, you don't change it because you've now found the proper setting. Does that help any?
Maybe.
I think I know what's going on, Ted. And I think David just said it.
I'm gonna go back to my getter.
It's the error that you're trying to drive to 0. Okay, you're not trying to drive a speed per se to 0. You're trying to drive the error to 0. Okay, so the value that gets put in your PID control is the difference between your desired speed and your actual speed. Okay.
Okay.
I've seen people when they starting off a lot of times that they'll do that. They'll just carry they just assume that the speed is their error. That's not true. The speed, that's why you might be going to 0. Do you see what I'm saying? Because you get up to where your speed is where you're saying it is, and so it's just dropping it down to 0. All right. Where if it's 0 as an error, then that means your setting is correct, and it'll just stay at that setting. I don't know if I'm being.
So, what I took away from what David was saying was that I needed to control the acceleration So when I had, see if I can say this, when my speed was at what I set the speed to and I had 0 error, then I'd have 0 acceleration.
Yes.
But what I'm missing is how do I control the acceleration with a throttle value?
Okay, well, let's is my mic on?
Yes.
Yeah.
Yep.
Let's back up to the simpler controller. You start off, you say it's just a proportional controller. So ignore the other values. And you have this error that becomes smaller as you approach the set point. And the set point that you want is not a position. That's another way of writing a PID controller. You can do a position controller, which is the first one you described.
I've done that before, and it worked.
The set point you want is not a position, but rather a velocity. So when you arrive, as you get closer and closer to that required velocity, the error that you're accumulating gets smaller and smaller. So now take that P value, take that P error, and integrate it. That integration is your output. Now, if you do that, what you'll find is that it flows back and forth across the set point because it's just a proportional controller. So then you put in the D value. This is like you have a car with springs and no shocks, and the D value is your shocks. So it will dampen that value as you cross 0. So this is the more conventional way of doing this is that the I value sits within the PID loop, and so basically it integrates up and holds whatever, but that for our purposes, for robots, it's more difficult to tune. This simpler controller is just a P and a D, and their output is integrated, and that integration is your accelerator pedal. That's your power that you send to the wheels to maintain the velocity.
And I will say this: there's many ways to skin this cat.
For
example, I like PI typically. Now I like PD for like line followers, but for just rovers, I'd probably use a PI. But David's been very successful, so don't discount what he's saying. I'm just saying there's different strokes here.
If you go read up on PID controllers, it's really it's not a thing. It's kind of like a toolbox that you can use different functions to do different things. And one of them is called feed forward. And feed forward is when you have a pretty good guess about what the output velocity power ought to be, and you mix it in, you send it ahead basically, which is what you were talking about. I don't think that that's a kind of a high level specialized control thing.
I don't think
it's not as hard as it sounds. I mean, you just need to have a reasonably good idea of what PW11 value you have to send it, to get to a particular speed, and then the feedback takes care of any variations in battery voltage and terrain. But knowing what that it's even just a little bit of trial and error can reveal a lot. You can get pretty close with feed forward. It's really not. Actually, there's no math involved. There's literally just a little bit of trial and error, and it's the better your motors are, or the more torque they have, and the less you're demanding from them. Actually, the easier it is to find kind of that number, and then let the feedback take care of, remaining variations that you just have to deal with.
Yeah, what I did is I just put the robot up in the air and drove the motors with no load at different throttle settings and measured the speed they were running, and it gave me a sort of linear line that I could figure out.
Mm-hmm.
Yeah.
If you do it with load, you get even closer to the reality, right? Do it with a nominal load, of some certain terrain, and you get an even better sense of what that number is.
Ted, I will say this: since you're using a Teensy, JC Jr., his website, I think he's the one that sells Teensies.
Oh, right, yeah.
Yeah, he has a wonderful encoder library that you can use that handles setting up your encoders. So you might want to look at that. And then Arduino, since you can probably use Teensy Duino. Yeah. Has a wonderful PID controller software.
Which I believe is the PID controller I'm using.
Yeah, it's
And it's
very,
good.
he has a whole set of what do they call it? Tutorials on how that library is written. Have you ever seen the tutorials? If
Right.
you-
Yeah. Oh, I've read through the tutorials a couple
Okay.
times now.
Okay, yeah, because it's
And-
really good.
Yeah. As far as the encoder library, a few years ago, I went through that and had figured out how to do encoders and the what do you call them, the pin interrupts.
Yeah.
And I took a deep dive into the assembly and wrote my own
Okay.
library for doing that, so I could be sure that the encoders were working correctly. So I have good confidence in them.
Yeah. I did, when I started out, one thing I did differently, when it all gets said and done, you're really measuring the number of encoder ticks per period. Okay?
Correct.
But that's not the way to think. Everything should be converted to velocity. Okay? So essentially what you do is you put that way when you want to set a speed or something, you say, well, I want it to go 5 inches per second. And now there's a little calculation that turns that into the encoder ticks that you need, and then another little calculation that you probably have for all your different feedbacks that you want to convert them, because you want to sum the velocities that's what the PID is on. You don't want to, but it all is encoder counts in the end. But it's so much easier to talk about things when you're talking in some sort of velocity.
Yeah, it's funny you mentioned that. Years ago when I started, I worked on Arduinos, and just because of the 8 bits and everything, all my calculations were done in integer math.
Mhm.
And since I've gone to the teensy, now I just use doubles and forget about the integers.
Yeah.
So much easier.
Well, Ted, one of the other benefits of going to velocity is that, like, for a long time I was just using, these sort of raw numbers without any conversion at all, and you'd see a velocity number which is 65 or something like that. It didn't really mean anything, and so it was kind of hard to tell what was going on. And so at one point I just sat down and figured out I made a Python script that basically just did a conversion into an actual measured value in centimeters per second. And all of a sudden I could actually, I could look at the robot and see actually how fast it was going and whether that number even made sense. The robot's not going 70 miles an hour. And that actually really helps debug things, as you can actually see visually what's going on, and knowing that the robot is either going like this fast or zipping by and it just passed a truck on the highway kind of
Yeah.
thing.
It also makes when you're sitting out on your floor and you're saying, okay, I got this robot and I want it to go like I said, 5 inches per second, and you have it run over 10 feet, and you use a timer, and you find out, dang, it's actually going 5 inches per second. That's a really cool feeling.
Yeah.
Ted, I can't imagine in a discussion like this that Kareem doesn't have something to offer. Uh-oh, he just popped off.
Yeah, I don't know.
He's running.
He's hiding.
He built a kind of a cool gadget to teach his team PID. That's a little pendulum that you can control the different parameters and watch how it behaves. And I think you mentioned there's also such a thing online, similar deal.
You mean like an
I think you know what it's supposed to do.
I don't know what happened to my camera. Can you hear me?
You'll
Yeah,
recognize.
we can hear you.
Yeah, we hear you.
Okay. Yeah, I was actually going to mention some. So yeah, PID tuning is a dark art. A lot of people claim it's easy. My robotics teams have a hard time with it, probably more because they have underpowered robots. So for the masses that they are trying to drive around, there is a very tight power budget, if you like. And so they run up against sort of like a windup of momentum that they can't control and things like that. And it certainly helps to have some sort of physical model for them to practice against. And I would love to know if anybody has good advice on how to tune in those situations where the power that you have for your motor is just kind of under where you would want it for good control over the physical system.
Well, I'm sure it's not news to you guys, but the only thing I ever managed to do for tuning PID was actually create 3 potentiometers for P, I, and D, and actually tweak those, so you could actually sit there and play with them. Because trying to do it as a changing a value in a program just takes too long.
Yeah, real time is cool. Yeah.
Yeah.
I was gonna say, you could rely on like the basic micro or ion motion controllers that have built-in PID tuning in them, and just run it, and it works great.
The first time I did a PID controller, it was for turning a robot so it would go straight to a nice 90-degree turn, nice smooth turn, and go out. And it felt so good when I got it to turn without doing overshooting or undershooting. Felt so good.
Yeah, I'm still in the ticks per interval. I mean, I have no idea how many inches per minute the robot's actually going, or inches per second.
Ted, when you get it working, one of the quick and dirty tests is, we're saying that in an underpowered range, when you run the robot really slow, that's an underpowered range. There's not much torque down there. And so you can really see the behavior of the PID controller much more clearly than when it's running up at a higher speed where it's all ballsy and robust. Truthfully, if you had a big honking motor with a real big, say 100-to-1 gear reduction, you might not even need the PID controller. It'd probably just go whatever speed you told it, So when you're down in those very low RPM ranges, which if you've got a differentially steered robot, the ability to drive accurately real slowly translates into the ability to steer accurately, since in a turn the inside wheel is going slow, and maybe really slow. So anyway, one way, so grab the robot, set it down, make it go real slow, and just grab it, and you should feel it tug at you. And when you let go of it, it should quickly slow back down. We were talking last week about the difference between the response rate to the control signal versus the response rate to the outside world. So your control signal, you might want to put a slew rate limiter on it, nice, pretty smooth. But when the outside world does something suddenly, you want to respond to that quickly. So, and that's the response rate of the PID controller. So you have a gain for the proportional value. Basically, you can think of that proportional value is going to be integrated to try to get you to the proper match between the feedback and the requested. And the larger you make that proportional value, the bigger that's going to be. So the faster you'll approach the waypoint. The set point. But the more likely you are to overshoot. So you can turn that gain down. Now you approach the set point very slowly. But when you get there, you're pretty accurate about being on it. So neither one of those is really what you want. So basically what the D term does is it allows you to kick up that proportional gain, because the D term, when it sees a big change, that's when it takes effect. So
it's going to be fighting the change, is my understanding, yes. Right?
Well, basically, if you picture it in your head, when you cross the set point, the signs reverse, and since they're out of phase, basically it tugs the other way. It tugs in the opposite direction. But even when you're a long way away from the set point, when you suddenly ask for a real big change, it sees that, and so it actually increases the rate more than the proportional would by itself. Does that make sense?
Okay, yeah, cool.
So that you're going to race more quickly to the set point, and you're going to damp it out when you get there.
When you get there.
Yeah, and as I say, if you just grab the robot, you ought to feel it tug and tug and tug at you, because it's got, even though it's running at full speed, it's got the full power of the robot there. It can keep ramping up until you let go, and then it should slow back down very, very quickly.
Yeah. Well, and like you said, with the skid steering, I want to have some control, and I want to be able to drive slowly for that cone and not just run it over. So that's why I'm interested in this.
Yeah.
But yeah,
That's a real
thanks
trade.
everyone. I can let someone else go now.
Well, Kareem, I have to agree with him that it's kind of dark art because those two values I described, just adjusting P and D, they interact with each other. So you can't just tune in the one and then tweak in the other. When you start adding in the other, you've got to go back in. So it's an iterative process.
It certainly is.
Yeah.
David, would you say that you try to avoid saturation? In other words, you may have 24-volt motors, but you have to get like 100% duty cycle, because then at that point you're open loop, or if it stays in above, or at 100%. You try to avoid that?
Yes. I think the simple answer is yes.
Yeah.
If you're skid steering or differential steering, you're speeding up the outside wheel when you steer, so the center of the robot remains constant. So if you're going 100%, all you can do is slow down the inside wheel. You can't speed up the outside wheel.
Right.
So I tend to, full speed for me is about 70%.
Okay. Well, that could account for, kind of a jerky motion, though, if you're going, say you're maxing out your PWM value, and it just stays up there for a while, and then, comes back out of it, or, if it's being driven so hard that it overshoots and then has to come back. And
I have to admit, the problems that Kareem was describing, and that I'm sure you're dealing with, Ray, I don't have experience with big, heavy robots that want to keep moving even after you tell them to stop.
Oh, okay.
Yeah.
Okay.
So, I think one way you might approach that is to, like, I agree with David. I typically do around 70% too. But you can, on a big one like that lawnmower, you might want to go to have motors that are running at 50%.
Mm-hmm.
Okay, so you just have that 20% extra reserve.
Have you ruled out brake mode, Ray?
No. I think
Are you using it?
Controllers support it. I haven't really played around with it that much, though.
Mm-hmm.
So, the motors at full speed, they don't cut grass very well when the whole thing's going that fast.
Mm-hmm.
So, I'm sure it gets from point A to point B quickly, but it doesn't mow that well.
Mm-hmm.
It's just too fast for the, for the blades. Maybe I should mow my lawn more often. Maybe that's the issue.
Yeah.
Well, since you don't have to do it, your robot's doing it for you. You could have it going every day.
Yeah, that's a lot of gasoline, though.
I thought you had an electric mower.
Electric wheelchair motors, but gas, and now I'm hooking up an alternator, so because my batteries really are a little too small, they don't have the capacity. They're riding lawnmower batteries, and they're smaller, they're lighter weight.
Ray, you may remember, there was a mention made the other day of Vicki Taylor, who was a vice president many years ago, when somebody first showed up with a Roomba. And so it was running around vacuuming the space, and all the members were sitting around criticizing it. Well, it's just this random pattern. It'll take forever to finish. And Vicki, probably the only person there at the time that actually vacuumed, she said, "What do you care?"
There you go.
Yeah. Well, I have a demo.
Okay.
Oh, cool.
It can be a gold star demo because it doesn't involve a robot, but it involves software. How do you share screens? Let's see. God, they keep changing the interface on this thing. Share screen. I can't find it. Anybody? Share screen.
I think it's present now. It's like the third one.
Present now, yeah. And then you window. There we go.
Right.
And I choose whatever. God, here we go. All right, share. Can't share. Go to system preferences. Oh, yeah, thanks. Okay. Allow, yes. Open. God, this is more complicated than I care. Can't share the screen. Why not? The Mac is telling me I can't share the screen. All right. Oh, God. Pardon me. I didn't realize this was going to be more complicated than I thought. Okay, now. Maybe, you guys just keep talking and I'll just all of a sudden interrupt with a shared screen, maybe. I have no
Chris,
idea what
you mentioned earlier making a test of the robot with some load, some known load, rather than just letting the wheels hang out in the air. And David actually made a device to do that. David, do you have it handy? You don't seem to have your mic on, Dave.
You made a robot dynamo.
It's a gadget to specifically put a load on the
dynamometer. Yeah.
Take it out. Yeah, I was just thinking basically letting it at least roll on the floor so it has to support and accelerate its full weight. You know, that it's kind of one step above sort of no load.
Did Murray just go away?
Yes. So hopefully he'll come back in a moment.
We are Murray-less.
I was thinking something like a treadmill, but that's complicated.
Well, check out what Dave has here. This is pretty cool.
I gotta assemble it here.
So Merrill, were you able to get it? We're not hearing you.
Give me a couple minutes.
Okay, well, in the meantime...
there we go.
He's presenting it right.
There we go.
Okay.
Murray's covering for you, Dave.
Okay.
Keyboard.
But it says mic on. We don't hear it if he's talking.
Okay, here's the beast.
Murray, we don't hear you.
Okay, sorry. Okay, you can hear me and you can see a screen now?
Yes.
Yes.
Okay, what you're looking at is a... Let's see if I get my mouse in the right place.
So Dave, after Murray's finished thing, we'll go to you.
All right.
Okay, I am SSH'd into my robot, and I am now going to run a test script that fires up the operating system. This is the Python operating system. It's now running. And so if I hit a certain key, I can start a loop, and the robot is stopped. There's actually no motors. This is all mocked. So there's no motors connected. In fact, you guys can even download this off GitHub and run this on your laptop. So there's a help key, and that's the help. So there's all the keys that it does. So it's actually in a loop right now. And so if I want to fire, let's say, the D key, which is the infrared, what is that? Infrared center, it fires an event. And then you get to see at the bottom down there which event. Its PSID is the port side infrared detector. There's the port, there's the center, starboard side, starboard side. Then there's the bumper port, bumper center, bumper starboard. So that's that little list. And if I keep hitting that sensor, you can see center just went away. If I hit, let's say, for example, this one, oops, wrong one, sorry. That back up again. What am I looking for? G, let's say. If I hit G repeatedly, gradually the starboard sensor goes away. So it's counting hits on each of those infrared sensors. Now, I'll show you the motors. Now, if we go back to help, along the top, the numbers are full astern all the way across to 9, which is full ahead. And I'm using the Chadburn description for, so I've got slow ahead, half ahead, full ahead. And so if I, let's say, for example, and there's a slew controller on this thing. So if I say 9, full ahead, it now begins to slew up. On the red is port, green is starboard. You can see it heading up towards 90, which is what I've got set for full ahead. And once it gets to that, it'll then do this. Now it's just sitting at 90. And then I can use again, there's my help. So the square brackets are increase or decrease port or starboard. So if I, let's say, decrease port and increase the starboard, it'll slew up to that. So this is basically a 1 second rather than a 20 millisecond loop of what the robot would be sending its motor controllers. And so just as a final demo, there's also, let's say, for example, spin to port, which is X. So right now we're running 45 and 100. And if I say spin to port, that's X, it'll now basically slew to the robot spinning counterclockwise. So that's basically and I can also stop it with what a stop is. A break is actually minus, which gradually slows to a stop. So it's now slowing down from a spin, it's slowing down to a stop. Here we go. Oh, I maybe have a bug. Is it not going? Oh, it's actually, I found a bug. It's not actually stopping. It's just bouncing around a value. In any case, I'll quit and quit sharing my screen. How do I do that?
That looks like a result of a lot of work.
I just raised my hand, but I didn't stop sharing. Here we go. Stop presenting. Okay. So that's, yeah, a bit of work. Thank you. What this represents is, I've got a graphic somewhere, but I won't try to present it all. What I'm going to do is actually make a blog entry that shows a video of this running and get a better description of what's going on. But this is basically a message bus that receives events on a bunch of publishers. So the publishers would be, for example, my front bumper and sensor array is one publisher. There's a gamepad publisher for this thing, and I've also got this keyboard publisher that publishes events onto the message bus. And then I've got multiple subscribers onto that bus, and the subscribers listen to specific events. So there's one subscriber that listens to motor-related events and only sends messages to the motor controllers. But I can have other subscribers for other reasons. For I might have a system subscriber that can shut the robot down when the batteries are low or something like that. But it's now running in a loop, and it's using the Python asynchronous I/O library, which was very tricky. In Java, this is a lot easier, I have to say. But in Python, it was quite tricky. And I don't know how this thing performs at speed. I haven't actually stuck it on the robot at 20 milliseconds and seen how it's going to actually run. As you can see, I've got a lot of console printing right now that I can turn off because there's a logger here, and if I put it in debug, it won't spit all this stuff to the screen at all. And hopefully that'll speed things up, because it's probably, with all this printing, probably pretty slow. But hopefully, I've got most of the bugs. So I just found one on, if you're spinning, it won't actually stop. It'll get down and do this thing. But there's probably lots of bugs. But it's been fun. I'm looking forward to, in the next week, taking what I've got right now, which is this mocked motor controller, which has all the slew control in it, but no PID, because that's on the real motor controller. But the slew is built into this controller, so that when you say to it, go this speed, you can tell. The slew controller is a class called slew limiter, and you tell it how fast you want it to slew, and that's adjustable. And so you can have it spin up to a certain speed or change speed at a given rate that you can modify. You can even modify it dynamically. So a control can say, oh, I want to slew fast, or I want to slew slow. And the message bus works both ways. So anything can send messages onto the bus and receive messages off the bus. So it's kind of the general, I hate to call this a subsumption architecture quite, but it's the basis for a subsumption architecture. And it's kind of like I don't know what to call it. I don't want to call it the modern equivalent, but a message bus is a relatively more complicated thing than, let's say, what David's doing. It does the same thing as what David's doing, but it's using separate components with a message bus and a publish and subscribe architecture, which is something you see in big systems, like I would develop for a corporation or for a business or something like that. So it's using this bigger architecture to do basically the same thing as a small loop. But it does have a lot of flexibility, and I'm hoping the performance will be good. So we'll see how it goes. It's at least functional now. And so now I can take the mocked motor controller out and try. It's actually running on my KD01 robot, so it will be almost trivial to plug in the actual motor controller with the existing PID controllers and see how this thing runs. So we're getting there. It's been a long, long time. It's been months I've been working on this bloody thing.
So
Anyway.
Dave, are you ready to show the? Okay, no mic.
Dave, we don't have any sound.
So Dave, can you turn your mic? There you go.
There you go.
Okay.
Okay. What it is it's a chassis dynamometer. Okay. And these wheels, you can see the tires onto a set of like drums. Those have an inertia that is roughly equivalent to the inertia of the robot. So that sitting here with the motors running, turning those wheels, it's supposed to simulate it running across the floor, but in place.
Very cool.
Yeah.
Okay.
What keeps the robot from running away?
It's the fact that there's a
Bumper or a cage.
there we go. You see, there's a peg sticking up, and there's a clip on that attached to the robot, and I can slide that back and forth to use different size robots.
Hey, Dave, how did you calculate the weight of those wheels in order to try to simulate inertia?
Okay. Well, I weighed the robot, and I said, okay, based on the other thing that's interesting here, so you can see it. We were talking about pots. There's the pots. One is for speed, and then the three are the I, P, and D.
Huh. Cool.
So for tuning. Okay. The inertia of the robot is based on its weight. Okay. Then I took the diameter of the wheels and computed the inertia of a drum. And so I made the weight and size of the those slugs of metal there the right amount to correspond to the inertia.
Understood. But is there I'm wanting to steal your brain here. What that formula would be very valuable if anybody else wanted to try to simulate the same thing.
Well, those particular nerve cells are sleeping at the moment. I would have to relook that up. It's something like the radius squared and the mass gives you the inertia.
Yep. Yeah, but if you can post that on the mailing list, that would be enormously valuable, because I'd love to do something like this, because I've got mine sitting where it just freewheels, and I totally would love to be able to get an inertial kind of output like you do.
Yeah. Okay.
Thank you.
I'll try to resurrect that.
Well, thanks.
Dave, you described it to me in an email one time. Maybe you can go find that email.
Oh, okay. Good point. Thank you.
I have a question for Ray.
Yes.
Ray, you were describing a electronic speed controller you have that has built-in PID functions, and I guess that means it also needs some encoders.
Yeah.
What is it?
It's the RoboClaw. I think it's the 2x60.
Yeah.
Okay. I think they're called Ion Motion now. They were like Basic Micro at one point, but I think that's Ion Motion is their latest name.
You mean the company name?
Yeah. Yeah.
Which is the motor controller I'm using also, but I hooked my encoders up to my microcontroller, so I don't have them hooked up to the speed controller.
Looks just like the picture here I'm looking at.
Oh, okay. Yep.
What are the amps on that thing?
2x60. But yeah, you can
amps or what?
Say that again.
Maximum amps or what?
This one is 2 channels, 60 amps.
They make them in all different sizes, though. That's the
Yeah.
big one.
But yeah, it works pretty good, and it just kind of, you know, you can set it down and it'll kind of jerk back and forth a little bit.
You remember how much that cost?
I thought
Is
I want
that
to
a
say that.
$100 device or is that a $10 device?
Oh no, I think it's 200, but I think I got it like for 150 on the Palulu, you know, Black Friday sales. So
Cool.
why pay a fortune for it if you don't have to? In fact, I think I have the. Yeah, this one I paid a little bit more. This one was 166, but I think one of the other ones that I got was 150. So,
And you're running those motors at how many volts?
24 volts. Yeah, they're just wheelchair motors basically. So, but
Hey, David, I wanted to chime in real quick and thank you for your presentation the other day. I wasn't able to make it because I was on the trip with my robotics students to state, but I finally caught up with it this morning and wish I'd been there to ask some questions. I had some questions and I've totally forgotten them by now, but it was great to see all of that content revisited. The main question I do have is, do you mind if I rip some of that stuff off wholesale when talking to my students? You're muted. I don't think I can have them sit down for a 3-hour tour like that.
That's absolutely my purpose. Yes, you can. Yes.
Thank you.
And thank you. And since you were off doing robot business and you're totally excused. How'd you guys do?
We did okay. We would have advanced to Worlds had it not been canceled. So we got second place in the Think Award category. And thanks to all of the, who put that filter on my camera? Thanks to all of the advice that we got from the presentations from you guys. Carl was very helpful. He did direct outreach to the team and helped with our portfolio. And that's primarily what it was on. Can't take myself seriously. Oh, the robot kids are messing with my filters, with my camera set up. Ah, it's gone. Okay.
I was going to say you could stand up and turn around and see if another one's coming from some other, you know, some other orifice.
I'll pass on that one.
Okay.
How many people are on that team?
We're down to so this particular team we were down to 9. I lost 3 students this year to attrition, and you know, 2 years ago I was doing 4 teams, and this year I managed to spin up a second team of 3 people. They made it to the regional championship, but they didn't get move on to state. Yeah, I think I'm not going to try to do that many at once again. You know, that was like 30, 35 students every weekend, and it was just too much.
Down to 9 people, you know, that 9 people is a lot.
Yeah. Yeah. Well, yeah, it's still a lot. Yeah.
We've had DPRG meetings with fewer.
Okay, well, I guess I'll have something to show you all when I start the rev. You might find this of interest, so I'll present that. So I went surfing the rev, And I found this thing. So, and it's sort of interesting how it drives around that. So, you can see there's basically 3 balls, and then there's the top view of mechanism.
So is it like a BB-8 but with 3 balls?
Yeah, well, after the
Well, it's not really balancing.
Well, after I finish the video, I'll show you the actual design. It's real hard to see the design here.
Looks wild.
Yeah, it's an interesting design. So that's why, yeah.
You can do that design with any number of wheels. It's,
Okay,
yeah.
so back. Let's see.
Or balls.
So,
Come
on. How do we get blue here? I don't know why
Okay, that's a bit complicated.
But yeah, it's you can see where you basically have these two, and that gets to this gear that then gets connected up in here, and then up here you have the driver that basically turns that. I don't know why. Yeah, and then there's another view of it. So yeah, it was sort of interesting design, and that, and then.
John, you remember we were talking a few weeks ago about having robots in competition that could do like hockey players do, where the direction they face is not related to which way they're going, which is kind of what that does.
Yeah, well, that's why I thought it was interesting. Yeah, they can literally go, any direction at once.
So if you need to point your bat, your weapon, whatever, in a fixed direction while you run around and avoid other things and other robots, that's pretty clever.
So yeah, and unfortunately, yeah, it would take a lot to print, but it could be done. I may eventually do that.
So
you're interesting.
So John, you have the files to print that?
Yeah, well, it's a Thingiverse 4675603. So basically what you would do is you go to here, and then there's all the files. There are lots of them, but you can see.
Would you think you'd lose a lot of energy to friction with all those gears and things?
I don't know. What do you think? I mean, it looks pretty.
It looks like a design that could be condensed, or simplified,
Oh, yeah.
If you think of a Curiosity rover with 6 wheels that has 6 independent turning wheels and everything with 6 drives, you could take 3 wheels off a Curiosity rover and do something similar and not have so many gears grinding.
Yeah, I think that was designed by a company that sells 3D printing filament.
Yeah.
Yeah, because it looks like, yeah, I don't know where these gears go to, but up here on the top, you got that gear going there, and so that gear is basically turning the direction. And I think the bottom one feeds, the actual gears to the claws to turn the ball, it looks like.
Yeah, the 2 black boxes are motors.
Yeah, you have 2 motors, basically.
Hey, John, click on the video that's in their files.
You want to see the video again?
Yeah, I missed it.
Okay. Well, I'll go with this one. But they actually have 2 videos on it.
Maybe it's a Rube Goldberg robot.
I was trying to avoid saying that, but yeah. Totally. It's like a very clever Rube Goldberg.
So that's showing basically, I guess, the fact that you can go.
John, are you hearing any sound from it?
Oh, actually, yeah.
What does it sound like? I always want to hear what it sounds like.
Okay,
like grinding plastic.
Well, okay, we've lost the picture. Okay, back. Okay.
Yeah, David, before you had came on, we were talking about early computers as we old guys do, and I was relating how I kind of liked the fact that old computers smelled, they made weird noises, and it's like, yeah, part of the reason to get into robotics is to get all that back again.
Okay.
I miss the flashing red LEDs on the front of the computer, so you could tell what it was doing. You could see it go into loops, you know. Now
So
all
you
we
able
have
to hear that?
the disk drive. That's all we have left is the drive light.
Just noise it slide.
I can't hear anything, John.
Well, if it's any consolation, I've actually sent in a proposal to Pimoroni to build a IMSI 8080 simulation front end that could be plugged into any computer, like into a Arduino or whatever, and it would have a whole bunch of address and data toggle switches and a bunch of LEDs, and then have a plug on the back you could plug to a Pi or to an Arduino or whatever. So you could actually have a 1970s style front end to a robot if you wanted. And if they build it, great. And then if they don't, there's this guy on the Discord channel who says he can help me make PC boards, and I'd go ahead and just try it myself.
But yeah.
You know, John, there's a robot similar to that you may have seen that is a balancing robot, and it only uses one ball, and it's
like
a bowling ball.
Wow.
And it drives
I've seen that. But this would be a little easier for the math.
Can it do a strike?
You mean, could it actually bowl?
Yeah, exactly. I mean, like, if you're going to get a bowling ball, why not? Go for it, you know? You champion bowling robot.
It's basically like, well, in the Star Wars, what was that?
Yeah,
BB-8.
Where they had the little on the top.
Yeah.
And then there's one other one. It's not as interesting as that, but I'll show you this. So this is the other one. This one's more plain. The only thing the reason why it caught my eye was their instruction set was a little better, and it lists all the parts and the different steps and that, so it was pretty good in that regard. And their demo looks like that.
Looks a little like the one Carl's building.
Yeah, it's pretty much like Carl's.
Carl can do that.
This one uses a Raspberry Zero, if I remember in their list. Yeah, Zero Fruit motor on it. So I don't know. Has anybody had experience with this motor controller?
Yeah, it's actually it's kind of a default they've had for many years, and they've got version 1.3 or something like that. It's kind of like the go-to board for controlling a pair of DC motors. I think actually maybe it holds. I think it does 4 DC motors or a single stepper, but it's pretty solid.
Good. Because that's what caught my eye was their list of items. So
yeah, based on the Toshiba 6612.
And you can see the batteries they use there.
Yeah.
That was caught my eye. Oh, and then they talk about the game controller, which I think uses Python, if I remember right. Down here. Somewhere down here, I think it talks about that.
So Ray, you're using the Adafruit controller?
Yeah. Yeah, that one's not a clone. It's actually Adafruit's board.
Oh.
I don't know if you can see it or not.
Yep.
But yeah.
They have repackaged that motor kit into a smaller package onto their Feather board too, which is a nice small I2C board that the library is compatible with it.
I thought this was, a sort of nice layout, well documented on their parts and that. So that was sort of the main thing, and the fact you could 3D print the body. It looks like they have little, like bumpers on the front too with stretches, or at least could. There.
Oh, by the way, whoever's in charge of the DPRG mailing list, the search engine is broken. I tried searching on Ackley Inertia, and it comes back with unable to read Word database file, blah, 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 blah. Did you run htdig? So apparently it's broken.
What do you have to go, did you go to the archives?
Yeah.
You're saying
I'm searching on the DPRG archives, and I do a search in the search box, and it comes back with an error message.
Yeah, I complained about that previously. It's been a while ago.
Well,
I have this problem.
Hey, Murray, and I'm sorry, Chris. If you can send me what the error message, I'll take a look at it.
Okay, will do.
Yeah.
As I said, it looks like this guy did a very good job of documenting that. And this, I don't know what this one will do, but it does something different. Okay, looks like the same as above. The one thing I was hoping was a little more on the camera part, but I didn't see that off him. But he's running the Python 3. So, for those people who are in Python, so.
Yeah, that's important if you use that Adafruit motor kit. It uses Python 3.
Yeah.
Well, in theory, we should all be on Python 3 now. I think it's what 3 years now. We're supposed to. They had gone from deprecated. Now you shouldn't be starting any new projects in Python 2. Took them like a decade or more to do that, but.
So that's sort of why I have things I ran across from last week. So anybody else want to share or show?
I got an interesting piece of feedback from a guy who's been using one of those Intel T65 depth camera plus IMU to do location. And he said he's had good luck with it. He didn't seem to have any actual numbers or measurements or anything, but the one thing he told me that disappointed me a little was that he had talked to the Intel engineers about it, and they told him he should point it upwards at the ceiling. And he mentioned that it gets its references off the ceiling, and that it was an uncluttered view. So that suggests that it doesn't work in a cluttered view, and also that it wouldn't work outdoors. I asked that question specifically, but I haven't heard back yet. But there's actually a lot of gadgets that can navigate by watching the ceiling.
So I've got one of those.
Oh, tell me what you know.
And so it actually works very well in a cluttered environment. In fact, it needs a lot of detail, right? And it needs to be non-moving, so things like trees waving in the wind, probably not so good. But I've done very limited testing outdoors so far. It's mostly been indoors. We decided not to use it for the team this year because when we tried it out in the space that I'm currently in, it ended up drifting an awful lot. And that's because this particular room is big and it has a lot of bare walls with not a lot of detail. When they tell you to point it at the roof, so there are some teams that have had good experience pointing it at the ceiling in their, but it's typically got to be a well textured ceiling, right? Can't be purely blank white or something like that, because then it has no reference to lock onto. But in those circumstances, it works pretty well. But in the room that I'm in right now, it's just white walls with no texture and not a lot of detail, and it doesn't work so well in that. It drifts a lot.
So it's sensitive to the environment that it's in?
Yeah, and it actually builds a map. So it's doing it's doing a sort of slam. I forget what they call it, but It's a limited form of SLAM. You don't have direct access to the map. You cannot export the map. You can save the settings, we haven't played around enough with it to develop a good idea of like how long that map persists when you move from space to space and things like that. So we've got a lot more testing to do, but we set it aside because we determined that for our situation it wasn't going to work. So it would have actually worked in our test area downstairs for where we do our robotics field testing, but it doesn't. It wouldn't work in like a gymnasium type.
Well, that's what I was going to ask. Is the gym ceiling too far away?
Yeah, probably it is.
Probably not enough detail.
And it depends on what, we go to different venues and you have no idea what's up there. What it looks like. So it probably varies a lot, but wide open spaces without a lot of texture didn't seem to do so well. But again, I haven't tried it outside. And remember, this is purely it just gives you your position in space from where it was first started up. You don't have access to like depth information, or you can't even get a camera image out of it. The T65, T265, if that's what you're talking about.
It's like an optical flow sensor, really.
It's an optical flow, yeah. With SLAM, with a limited SLAM.
But you can't get to the raw data from the depth camera and the IMU that it's using to
no, they've got something 45. I can't remember what the other one is. I've got that one also. I haven't played with it much, but it's a stereo with that does give you access to the depth frames.
Yeah.
And in most of their demos, they show them using both of those cameras at the same time.
That's right. That's right.
Yeah. I think it's
where they're navigating around the moon. That's right.
Yeah.
Yep.
So if you want an obstacle detector, you want the depth camera, not the tracking camera.
Right.
Well, if you get bored playing with yours,
I'll send it up north. Yeah. Actually, I'm fully open to that if you want to borrow it for a bit. We're switching back to the for the summer. We're probably going to be playing more with the depth camera.
Well, you should keep us updated on all that, because I know nothing about any of that, and I'd like to.
Sure, be happy to if we figure it out. I'm not sure I'm going to get around to. I'm still hoping to field the robot for the Robo Columbus whatever thingy, but I got a lot of other things I got to accomplish this summer as well. So.
Yeah, I mentioned before, I found out that I could do 95% of my job from home remotely.
Right.
Which had advantages and disadvantages. One of the disadvantages is that other 5% accumulates.
It does, yeah. We're about to go back into working at the office, so about to transition back.
And we just had somebody from Australia come over to Wellington and walk around the city with the nasty version of COVID. So we may end up in lockdown for the first time due to an actual outbreak, and we don't know yet. Just happened yesterday.
Oh wow!
Murray, are you vaccinated?
No, nobody is here because there's not been anybody walking around with it. And I think it's been a very slow vaccination because. And the problem is that I wear a mask on the train because the Parliament passed a rule, which people don't understand is the same as a law. And so if I get on the train with a mask on, there'll be 5 or 10% of the people refuse to wear masks, typically older guys or young girls. And I've asked the conductors, and they say that they've been told by the city council not to enforce that rule because they don't want to create conflict. And therefore, we've got this. And because there's not been any community transmission for like a year in New Zealand, people have gotten really, really lax here for the wrong reasons. And now if we get an outbreak, it will probably spread like crazy because no one has the right behavior.
You don't know what type of version it is.
It's whatever the I can't remember, Delta or whatever it's called.
They have Delta.
Indian
That's the one from India, and a
Yeah.
guy from Sydney came here somehow and walked around and then went back, and then it's just amazing. So we're going to see in the next 10 days whether we've got an outbreak or not.
Simply can spread more easily, about like 40% easier.
Hopefully, it's not going to be like we did in America, where a lot of people refuse to wear masks.
Well, there's a lot of people here who refuse to wear masks.
Yeah,
like anywhere. I don't think that Kiwis are any smarter than anybody else.
Yeah, around here they also shoot people if they do or don't wear masks, and they argue about it.
Yeah.
We don't get that, thank God. Not so many guns.
Hey, Kareem, have you heard of it's Lex Honest Oak D Depth AI sensor? It's SparkFun sells it.
No, I'm not sure I can even put that into words. Say that again.
Okay, it's Lex Honest, LUXONIS. It's and then Oak OAK/D. Depth
AI camera.
AI camera. Yeah.
I was able to search it.
Yeah.
I'll take a look. I'm not familiar with that one.
Yeah, it kind of seems it'll do like object recognition and tell you what the depth is, and you have access to both the depth imagery and just the plain camera.
And you can train it, or I'll have to take a look at how you train it.
I think you can train it. I think I forget which model it's using. It'll recognize like people and laptops, desks, chairs. I forget which one it is.
There's a strange rule in our in our competition rules that it has to be a web camera that responds to. Oh, now I'm totally blanking. UVC interface protocol, something like that. And if it presents that way, we can use it. And the T265 does. But I'll take a look and see if this offers them a solution.
I'd be real interested if you get one and test it out, because I got one.
You got one?
Yeah.
All right.
Yeah, it's I got it as part of their. It's OpenCV Oak D, and it's part of their. It was a Kickstarter, and I went ahead and supported them. And it's a gorgeous piece, but I don't have time to. If I'm going to compete, I don't have time to mess with that. I got to mess with the other stuff. I got bigger problems. So
someone posted a couple of years ago, and I thought it was a Kickstarter. Maybe it's that same device, but it was, a camera you had to train off board. Use your desktop to do the training, but then it could recognize objects and return depths. Is that the same device?
I doubt it. This was just this last year. It's probably a predecessor of it, David.
Let me see if I've got a link here somewhere.
But if you look up Oak D, it should pop up. Oak-D.
I'm posting a link in chat. Is that the one you're talking about?
Yeah, that looks like it. Or you can see it on the SparkFun website. And they had a video, and in the video they described which, how you train it, or how what it uses, which models it uses, and I forget which one it is, but.
Yeah, that's it.
Yeah, the thing is mostly metals, and it's using a super fast processor. So I imagine it takes quite a bit of current to run it.
Yeah, the T265 is pretty good about current. This one looks like it's doing pure stereo decoding, not using any structured light.
Yeah, I think it is. Yeah, it's basically two. I want to say the
Two camera
the ones
systems.
that sensing are global shutter, or maybe the other one's a global shutter. I forget which is which now. But hey, Doug, do you have the power supply for that thing? What's the power supply rated for?
3 amps.
Oh my God.
Oh, but that might be. I mean, I just think this is a standard.
Oh, let's
yeah.
hope so.
Yeah. Well, I mean,
15 watts right there. Wow. That's a lot.
I just bought a new camera I've been playing around with.
Tell us more.
Tell us more. I'll show you a little bit here what I've been doing. If I could present my screen.
By the way, I found the email that David Anderson mentioned and tried to send it out to the DPRG mailing list, but it wasn't successful. So I sent a copy to him and asked him to forward it.
So I don't know if you guys can see that.
Yep.
Yeah.
Basically, took half an image, and way over here, I put my Visi vest on top of my fake trial cone. Yeah, the trial cone wasn't orange enough, and I was able to extract the image and to pick up the orange,
cool,
or the variations of orange. I'm doing between two colors, and so that's picking it up. I haven't tried it outdoors. I want to get outdoors and see if I can capture it in daylight. The camera I bought gives me stereo images.
Whoa, neat.
So it's a single picture in stereo.
Yeah.
So about 80 millimeters, I think 70 or 80 millimeters apart on the lenses. And which is nice. I don't have to play with syncing or anything else. The pictures are always in sync. So I've been playing a little bit on that, and I'm trying to get some, trying to find the colors, and then the next one is going to be a depth map.
Ooh, the depth map one I think will be challenging.
Well, it's on a Pi running OpenCV. Hopefully it won't be too bad, but it depends how much calibration I have to do between the two images.
Yeah.
Pat, are you doing Python or in C++?
I'm in Python right now.
And you're using, oh, yeah, okay. I was just going to say, I had played around with the Pi camera on this one, and just, if you basically work entirely on, swap your pixels over to measuring by hue, and if you get the hue of that orange, then it won't matter what the lighting is generally. And I was able, I don't know if you guys remember, but I was able to get a pink LED at like 3 meters on a regular Pi camera and be able to find it. So I would, and that was the only trick I was doing, was just basically taking every pixel and changing it over to measure by hue alone.
Okay, just looking at the hue as opposed to hue saturation, essentially, instead of I'm looking at a BRG color.
Yeah, well, it's easy swap in the Python libraries. You can easily swap over from RGB to hue, saturation, and lightness, or whatever it is, and just go on hue alone. And I was getting pretty good results.
It's called YRB.
YRB. Yeah.
YRB. Basically, the RB is the color, and the Y is the brightness. So you can loosen up the brightness, allow more range in the brightness, and tighten up on the RB on the particular color that you want. So yeah, I found that. Pat, one of the things I've done before with in the long ago when we had stereo pictures in the geology. You can put a piece of cardboard. Do you know this trick? Put a piece of cardboard right in front of your nose and put the picture right up against it, and let your eyes, make a single image out of it, and you can see it in stereo. Have you tried that?
I haven't tried it with the pictures, no.
I just now tried it with the one you had up on the screen using my hand, but I can't get my glasses to focus up that close.
Yeah, I don't know if the distance is right between the eyeballs at 70 or 80 millimeters.
It won't matter.
Okay.
These things, they had these tripods with cameras way out on the ends of them. They might be 8 feet apart, but as long as they're from two slightly different angles, your brain does all the rest.
Oh, well. I'll give it a try at some point.
You get increased depth perception if the further apart they are.
Okay.
Is that why they do that? I've seen, the military has these binoculars that are way out on, big bug-eye things.
Same thing, yeah.
Or it kind of goes out beyond, the distance between your eyes. The lenses are out like here, and
I've seen ones where they look like they're 6 feet apart.
And part of the reason why the telerobotic cameras on all the Mars rovers are actually roughly the same as human eyes is that the system is designed to actually, I think I might have described this before, they have a pair of eyeglasses with a little infrared sensor right in the middle that syncs up with the television, and you basically have the strobing of the left-right images on the television. And so what you as a human get to see is what the robot sees in 3D, and they don't want it to be any further or closer, so they want to sync up with what a human would be seeing. Because I think that what they found was that if it was any wider than that, you'd actually, over a period of time, like if you looked at this for too long, you'd actually get dizzy, because our eyes aren't way out here.
I know some of you guys know Mark Sims, and some years ago he showed up at my office, and what he had was a little gadget that had a TV transmitter, but basically he had 2 black and white cameras, and it if you know television, there's an interlace. You draw half of the picture, you go back and draw. So what he was doing, he was drawing one camera in one half of the interlace, the other camera in the other half. Then we put on these goggles that had LCDs in them that would switch those on and off so that your eye only. And it worked great. We put it on the little robot car. You drove around and had 3D vision. I'm talking maybe 20 years ago.
Well, that's how they used to have 3D in the cinemas as well, right? Not the blue-red 3D of the 50s, but if you went to a 3D movie in the early 2000s, you put on those glasses that had polarized 90-degree polarization. But there were some cinemas that had the ones with the LCDs that would sync up like the NASA ones.
Wow.
Well, we like this because the TV stream we had was only, a mono TV signal we could send back stereo signals by.
Oh, yeah. Interlacing.
Yeah. So, Pat, are you going to try to do, make a depth perception or,
Well, definitely I'm going to do a depth map. So as I get closer to where I'm going, I'll probably be using a depth map.
Yeah.
And to try to get an idea where everything is.
Do you have a starting source of code? Because that is not trivial.
Oh, it's everywhere on the net.
Really?
There's I've seen plenty of examples. It's enough to get it going. If it works, it works. If it doesn't, well, we'll fall back on GPS and just one single camera.
No. If it doesn't work, Pat, you're going to make it work. You're going to figure out what they've done wrong. And
well, that's what I used to tell my boss at work. That so far, he says, "How's it going?" Great. I found 3 ways not to do it today.
Exactly.
Robert Feynman. Richard Feynman. Richard, the Nobel laureate, said when he worked on a new project that he tried to make it a point never to read anybody else's work because he said it would, pollute or contaminate his ideas.
Well, that's it. They teach you to.
Richard Feynman can get away with that.
If you're a giant, you don't need to stand on the shoulders of giants.
One of his colleagues said that the problem with Richard was that you couldn't keep his method, to a whole new generation of college students, because he said his message was that he would write down the problem and then he would think about it really hard, and then he would write down the answer.
Well, I remember one of Feynman's descriptions where he was explaining the smashing process of why they were going about smashing atoms and what have you. He said, well, we're trying to figure out what's inside of it. Imagine that you took a watch, you smashed it, and then you looked at all the pieces that came out from it, and from that tried to figure out what it was originally.
Yeah.
That's like that Greek celestial thing they found.
Yeah.
Yeah, the something mechanism, the actinarial mechanism.
Yeah.
Antikythera.
Don't even try, man.
Sounds like Greek to me.
None of us actually can speak Greek, can we?
No.
So, I wouldn't even pretend to pronounce Greek.
Probably part of an ancient wristwatch from a giant civilization on Earth a million years ago.
That's the best bet.
I know pictures.
You know, I watch when we're thinking about guessing what things are. There's a show came on, Buck Rogers in the 25th Century, back in the 80s, and similar kind of things. They would hold up this hair dryer and goes, "We think this is an ancient torture device." You know, just they have no idea what it is. It made them crazy things. Always made me laugh. So maybe we're making up crazy things here too. But maybe it is a wristwatch. Who knows?
Anthropologists will almost always say, if they can't figure it out, that it was certainly some sort of religious artifact.
It's like everything tastes like chicken, right? You can't figure it out. Well, it's like chicken. What the heck?
My hair dries like chicken.
Yeah, hair dry for chickens, exactly.
Well, I was trying to explain to somebody, we were talking about the far distant past and the far distant future, and they were talking millions of years as if humans were going to be around in a million years. And I tried to point out that humans are only about, 150, maybe 300,000 years old as a species. A million years from now, even if the world didn't have some big cataclysm, in terms of climate or whatever, a million years from now, we're going to look like garden slugs. I mean, we won't be anything like humans. Even if our species survives, we will have evolved into something entirely different. A million years in the past, there were no hominids, there were no gorillas.
Weasel or something like this big.
Yeah, I think there's evidence for us that we can see now. I mean, if you're driving down the road, I think there's a law that every third country house that you see in there has to have an old bus that's beat up and broke down that somebody's eventually going to try to turn into a camper, but never happens. And if you go and look at all the aging houses and aging barns and stuff, some of those things are not even 100 years old, and you can't hardly tell there's a house. Wait till they're 1,000 years old, you're not even tell they're made of wood. And in a million years, like you're talking there, Murray, you might have a couple of molecules of something that was left that you could recognize as one of those things. So there's no telling what it's going to look like.
But there is something different now that there's never been before, which is we have taken control of our
Yeah, so something will go wrong, and that manipulation will all turn us into a bunch of gray goose. We'll be slugs, like Murray said. So we're good.
How do you know we're not there already?
You're very right. We don't know.
I like the one that says, if we evolved from apes, why are there still apes?
Well, they're, of course, as evolved as we are. We didn't evolve from modern. Murray, the anthropologists I work with, there was a talk I went to. Basically, they break this down into, there's two different theories. There's one group that says that modern humans, Homo sapiens sapien, wise man, in all our humility, are about 30,000 years old, and that's based on the sudden blossoming of all this cultural things that happened about 30,000 years ago, where suddenly you have artwork and you have ritual burials and all kinds of other things. There's another group that goes on bone records and says, no, we're about 300,000 years old, much older than that. And there's a lot of strong evidence to that. There are fire pits in the Levant that are at least 1 million, maybe 1.25 million years old. The pits where the beings, these are not modern humans, that these are our ancestors.
Hominid.
Building fires and maintaining them over thousands of years. So whether you call that a modern human or not. But the guys I work with say, no, it's 300,000 years old. And what happened 30,000 years ago was a sudden cultural explosion and not a change in our DNA. And one of the arguments they make is, look at us right now. You know, humans basically lived this agrarian lifestyle for thousands and thousands of years. And then within 100 years, you know, we industrialized and put a man on the moon. Looking back, you know, 500,000 years from now, you might say, well, there must have been some huge change in their DNA, in their genome. But there wasn't. It was a cultural thing. And that may have happened multiple times. You know, the first guy who said, instead of going out and gathering these plants, why don't we just plant them in the ground right here next to the teepee, you know, was a genius. He was a genius of his day, you know. So we don't know how many times that's happened.
Well, do you remember a coffee table book from the 1970s or 80s called the Origins of Consciousness and the Breakdown of the Bicameral Mind by Julian Jaynes?
Yes.
It turns out he was actually, it's a beautiful white book with big black letters in the front, and it just really impresses girls, you know. But it turns out he's been kind of discredited, but the premise is something I totally agree with, which is that the biology that he was describing is probably not real, but it agrees with what you're saying, David, in that our evolution now is not at a gross biological DNA level. It's that our brains now are structurally changing, and that Jane's premise was that, and he looks to literature, actually the changes in literature going back about 3,000 years, that the idea of who we were, our sense of consciousness of our own being, changed around 3,000 years ago, and that I think, as you're saying, that we're now past the industrial age, and now with modern communications and the way we operate as humans, that the types of changes that are happening to us are now entirely within the structures of our brains. This isn't a DNA change, but because our brains are so dynamic and so powerful and so able to be fluid in their structures, that we are now evolving internally, not in terms of our DNA.
Well, to bring that back to robotics, if I'm allowed. Did I interrupt you, Kareem?
I was just going to say I'm very highly impressed with humans the way you're speaking right now. I would offer a counter proposal. I would offer a counter proposal that yes, we've been able to sort of accumulate or sort of keep up with the changes up until now, but I think we're at another inflection point where the rate of change is getting beyond our capability to maintain a common culture as a result of it, and we might be at a I don't know. I worry about the future of the human species, and I believe that our robot overlords will really take over at some point, and that's why we have this hobby, right?
Welcome.
Yeah, we're trying to have some tiny little bit of say in how we get replaced, right?
I would only relate that back to robotics in the following way. If you go back to the beginning, or what we know about the beginning of life here on our lovely planet, basically everything that is transferred from one generation to the next is transferred in the genome. That is, all the information that microorganism needs to reproduce and survive is transferred genetically. And as life gets more and more complex, you eventually reach a point where that doesn't work anymore. As a matter of fact, you've already reached that point. Viruses themselves are basically just strings of RNA. And strings of RNA are limited into how long they can get because replication starts to introduce so many errors that they can't be replicated. So there's a fixed practical length of how long. If you want to get longer than that, longer than a few thousand codons, you have to go to DNA, which is this error correcting mechanism, and now you can have them billions long. So you can get a lot more information in the genome. Nonetheless, eventually you get to the point where the amount of information that's passed from one generation to the next is larger than will fit in the genome. And the organ of that transfer of information is the brain. So a baby duck knows how to swim from its genome. It's born knowing how to swim, but his mother teaches him how to forage for food. That's transferred from one brain to the next. In a very generic sense, that's what culture is. Culture is the information that's extra genetic that goes from one generation to the next. Now, we're nowhere near that on our robots. We haven't even begun to fill up our strings of RNA. You know, we're down at that level. But eventually a point will come where the amount of information that needs to be, that the robot needs, that the artificial intelligence needs, is larger than the amount that we can give it. And it will have to develop its own mechanism. If you think of our progress, you can follow that as a constant line. First, you have the brain, so you can communicate more complicated information. Then you have language, so you can really communicate complicated information. And rather than just watch me do something, I can tell you how to do it. Then you have writing, so you can learn that from a dead person or a person a long way away. And you have libraries that have more information in them than any one human can ever know. And the printing press, telecommunications, the internet, all of those are a natural flow of this mechanism for trying to pass information. And so I'm less pessimistic than Kareem is. I would use a musical analogy. When you hear an event, you can count those events. And the faster they go, they start to blur together. And eventually your brain switches over from counting events to hearing it as a tone. You have to change the way you listen to that sound. And you can tell how fast it's going by the pitch of the tone. So we may have to develop a new way to listen to the rapidly changing environment.
Cool.
Neural implants, maybe. I don't know.
Just a different way of thinking.
It's entirely possible, but then you've also got this. So a couple of different thoughts. This is stuff that I've been thinking about for a long time too, and I'm not going to try and defend my skepticism. I'll just say that maybe I feel inadequate to keeping up with the rate of change personally, and I'm not going to broadcast that onto everybody else. So one of the thoughts I have is that culture itself is, I'm waiting for it to get smarter, right? So culture is the mass effect of many human brains working at once, along with the artifacts, and then the information that they contain. But if you look at if you take bits of culture out and say, maybe I'm gonna represent the American political system as a submind of that larger culture. Mm-hmm. How smart is that submind?
Not very
Is it smarter than a person? Is it wiser than a person? Right? Maybe not, right? So the individual intelligence still resides within us, but then we can make huge mistakes as a group, as a culture, and yet we can preserve amazing things. So I think that the spectrum is huge. The other thing I wanted to say was that yes, robotics are incredibly primitive right now, but they're evolving at a rate way faster than we are as humans, way faster, and so that's going to accumulate over time, and that also seems to be increasing. The rate at which they're evolving is increasing as well, and so at what point does it get away from us? I'm not talking about it might be a Skynet type of situation. I'm not really concerned about that kind of thing, really, but the question is, how do we coexist with? They may not care. I think my primary theory is that they'll just see us as a useful nuisance, and as long as we keep their systems going, and up until such time as they don't need us to manufacture them anymore, We're just, another side effect of the place they happen to be at.
Soon, all the people will have all at once in a free marketplace.
Yeah, but you're making an assumption that they can think. So that would be the first question. How do you know when they can think?
How do you
know
prove we can? I mean, that's, we can get into a big philosophical debate. It's going to be a while before they think abstractly like us.
Right, and that would be
But maybe not as far as we surmise, right?
And that one point you were making about trying to sort of evaluate the intelligence of a civilization or a culture or something like that. I mean, you probably have read some systems theory, I assume.
Yeah.
And it's one of those things where the problem, I think, in 2021 is that the necessary feedback loops where there's lots of intelligent people around. There's lots of stupid, dangerous people too, but there's lots of intelligent people. But the feedback loops aren't set up in society where the results of intelligent decision making and intelligent conversation end up promoting or helping our society. Here we are having conversations around stuff, but nothing comes of it except for us building robots. But the people who are actually in power, who make decisions that actually affect us, like oil companies and all that business, those decisions aren't made by particularly intelligent people or in particularly intelligent ways. They're made because of money or whatever. And so we're not benefiting from the intelligence that we might even have as a society. We're seeing the results of power being played out by the big players.
But they are intelligent people, and they're making intelligent decisions within the context of what motivates them, right?
Yes, the greater good.
This may be one of those glass half empty, glass half full things. Who told the engineer joke? Was that you, Dave? About, the optimist says it's half empty, half full, and the pessimist says it's half empty, and the engineer says it's just too big.
It's too big.
And glass is too big. But
it's all based on what they're relative to something else, and they don't have that connection. Hence, they're making a decision based on whatever.
I would take a slightly opposing view. I had a friend in college, Scott Morgan, who's a really bright man. He was talking one time about how poor communication is. He said, I have this idea in my mind, and I have to turn it into words and make these pressure waves, and they go and make pressure waves on your ears, and you have to try to turn that back into a meaning that's approximately what I started with. And he was just at despair that process didn't work better than it does. And my thought at the time was, I view that completely opposite. I think it's amazing we can communicate at all.
Yeah.
At all. The fact that we can do it as well as we do it, is astounding to me, even if it's not perfect.
And
I think we're driving everybody away.
I did want to point out one thing, which is kind of before we get back to robotics, is that one book that really blew my mind in the last couple of years, which I might have mentioned before, is by a journalist named Peter Brannon. That's Brannen, Peter Brannon, called The Ends of the World. And it is the first time I've ever read a really well-written book, nonfiction, but with that kind of sense of things happening, that talks about the beginning of the Earth till where we are now and what looks to be the future, in the sense of how the Earth has evolved and how we went from a globe covered with water, where all of a sudden things started growing and sucked up all the oxygen, and then that caused everything to freeze. And we went through multiple periods of the Earth going through these attempts at getting to different things in different types of equilibrium, but that what I got out of the book is that we simply are the species. It used to be trees that did this. Now we are doing the same thing to the Earth. And 1,000,000 years from now, we'll be long gone, and the continents will have turned over a few more times, and it'll be some other species that will suck either all the oxygen or all the carbon dioxide out, and we'll either go up hot or we'll go cold again, and it all just goes over and over again until 3.5 billion years ago from now. Poof,
I have a much more optimistic take.
I didn't think that's optimistic. There's nothing wrong
There used to be these things called red beds. If you ask geologists about them, they're not formed anymore, but they're on the bottom of the ocean floor. It was these little critters, and their waste was oxygen. At that time, the oceans and the atmosphere was not oxygenated. So what they did was they oxygenated the ocean, and eventually that oxygenated the atmosphere as well. But this was poison to them, and it killed them. So what made life available for all of us oxygen breathers actually killed the people who made. Now, I can't help but think that we're probably just doing the same thing. That is, we're going to be a more highly refined oil for some long future. My best bet is like cockroaches, 6-foot cockroaches that can live on radioactive rocks. And they tell their children, you know, before the hairless monkeys came, this planet was uninhabitable.
He ain't heavy. He's my brother.
Yeah, this is something.
And that was more optimistic, was it?
Yeah, it's naked lunch.
Yeah, we're a highly reformed oil for some future machinery.
We're sludge.
As long as we're part of the progress, I'm okay with it.
Yeah. Well, David, I didn't take the Ends of the World book actually in any way pessimistic. I thought it was kind of like, look, we're just part of this natural process that everything's going to be fine in 350 million years. That's fine. That's cool. I like that idea. I like the idea of a giant cockroach smoking a huge, doobie going, yeah, look at them guys. We got photographs of them, and they were like thinking they were so smart. And they got these massive cockroach brains. And
no, they're grateful to us. They're grateful to us for irradiating the planet for them.
Yeah, yeah. And they're worried about the rise of robots.
Okay, I can't imagine us getting any closer to robotics than that. So, good night, gentlemen.
Yep. Yep.
Good night.
Right.
Okay. So, Ray, before you sign off, one question. Do you hear anything about Moon Day or whatever? Or do you get any feedback?
No feedback yet. I'm going to have to call him again, I guess. But
Okay.
Yeah, I talked to the wife a little bit about that Moon Day thing. She seemed like she thought it might be fun. So I went tentatively there with my my ExoMi to run around because we can definitely control it with the 710, the controller.
Yeah.
And have that run around. And also maybe by then I will have the camera pan and pan, the tilt and pan. I've got that being controlled through ROS. Now I've got that configured into the ROS, and now I need to make it where it controls and hook up a joystick.
Right. Because I was going to say, I think I know my robots tend to have been sleeping for the last year or so. So I would have to pull stuff to.
You have to blow some dust off, huh?
So,
Yeah.
I'm to the point where I need to write some nodes now in ROS to start reading data and publishing and have some subscribers, pub sub stuff to do something. First get the data, then do something smart with it, and then we'll worry about how to make AI and act on the GPS and all the other junk that's flying around in there, which I think is probably the really hard things to do, and it's taken me this long to get to the hard stuff.
So Ray, you might ask regard to how they were doing virtual. Will they have a fast speed internet connection that we could plug into, or for people that want to, or will they have to sort of download a file that we could play on?
Yeah,
there would be my thought there.
That's what I asked him pretty much. How
are they going to do the remote aspect of it?
Oh, the remote? I might be able to help there.
And that's why I said I could see that they could do a remote effectively by taping it ahead of time and then play the tape, Because to me, that effectively is a remote.
Well, they could
it's not live.
The way we allow them to do it is they can either do it if they're supposed to run it on the same day.
No, I'm talking about Moon Day. Okay, well, I said tape that. Right.
I'm sorry.
How are they going to do this virtual thing? I'm thinking, well, virtual could be tape.
Yeah, it could be.
Because to me, that is virtual, effectively. Back to the argument of, what's real, what's not real, but type thing, but, So, anyway, I just was curious if you had gotten feedback or what.
Not yet.
Okay.
So
I'm sort of looking next month. Already
about a month away.
at things.
Let's see that.
In my case, there's actually a couple other things I'm doing, like, a brassmithing thing, a kayak thing. So, hence.
So essentially, Moon Day is off, right?
Right now.
Yeah.
Well, we haven't
Yeah.
got any feedback, so it's hard to plan if you don't get feedback. But other than it sounds like we have the one robot that could be shown display. And I have something from wherever, whenever, but it's been a while back.
Mm-hmm.
And then as far as the virtual aspect, we don't have any feedback at this stage.
Okay. Well, are you guys want me to stop recording now?
Well, yeah. In fact, I thought, okay, yeah, you may want to edit this out, this end part, but yeah.
Okay, well.
I was going to say